we're going to get started, and I was really hoping that I had the internet, but I don't have the internet because it's hard to get on Wi-Fi here. And so what we're going to do is we're going to spend some minutes gathering up questions from the crowd who's here right now, and then I'm going to try to get some idea of what would be the most interesting to people. Because for me, a big part of the interesting part of this for me is, what do people actually want? I try to give a presentation at Minnebar every year because that's the fun way to go to Minnebar. But I never really know whether it's something that people will be interested in. Now I'll be able to get a better read on that. So I'm going to type in the questions that were submitted so far, which aren't very many. And then I'm going to solicit some from the audience. So let me try to, and it looks like I'm using Google, but actually we're offline. I'm using Google offline. So let me type in the 3 that are here, and then I'm going to solicit you all. I guess I'll tell you a little bit about myself as well. Just a minute. What character? That would be great. I tried to use my phone's hotspot, and it was really not working very well. But maybe yours will work better. That would be awesome. What's it called?
That one, 249.
Boop.
And it'll say, you just want to say blah blah blah.
Blah blah blah.
Something's wrong.
Right?
You just no H's. No H's. Get rid
No
of
H's. Like that. Join.
How about that? Yeah.
How about this?
Not now. Try now. Try now. Thank you, Steve Jobs.
Look at that. Thank you. Saul messing. So instead what I'm going to do is I'm going to type things into here. These 3 are already in here. And then you can hopefully scan that QR code with your phone, and you can upvote things, and we'll answer things at the top of the list. That would be ideal. So maybe at this moment, I will tell you a little bit about myself real quick. Oh, people are scanning. That's good. We're scanning. Lots of scanning. You can type stuff in there as well, but thus far it'll be just upvoting. Lots of scanning. Still scanning. Because as soon as I tell you about myself, I have to switch away. So there's scanning, but I'm going to switch away. Sorry, there will be more scanning later. So this session is Data Science Q&A. I'm Dan Frankowski. There's my email address, and I'd be happy to answer questions by email. I've worked at a bunch of places. Some of these are startups. Net Perceptions, Blue Shift, Condorcet, Arasi, were all startups. Code 42 is mid-sized in the Twin Cities, and then I've worked for Google, Amazon, and Pinterest. I worked almost 6 years. So that's a little bit about me and credentials. I worked as a software engineer or a data scientist. I was data scientist number 3 at Pinterest. And that was an interesting experience. So I have some credibility to answer data science questions. But I attended a couple of sessions here. And a friend of mine has kindly called me the best data scientist in Minnesota. But I think I'm probably not even the best data scientist in the room right now. I've heard a lot of stuff that I'm not qualified to answer. And if I'm not, I'll just say I don't know. So the first thing I wanted to tell you about is what is data science? Because if we're going to ask questions about it, maybe we should try to agree on definitions. Nate Silver, who I know that my friend Saul here hates, is I think data scientist is a sexed up term for a statistician. Josh Wills says a data scientist is a person who's better at statistics than any software engineer and better at software engineering than any statistician. So some kind of mix between computers and statistics. I claim the difference between a software engineer and a data scientist is confidence intervals. And specifically, that's also related to statistics. But what I've seen software engineers do a lot is they go and they grab some data and they use it regardless of whether they should use it or not. And data scientists usually have some idea of whether they should be using the data and how confident they are in it. Some people say a data scientist is a data analyst who lives in California. That's sort of a joke that, well, if I put scientist after my name, I can earn more money. And it also reflects that tech startups in California have had a large influence on this field, I think. My friend Saul, who's sitting here in the front, says it doesn't mean a damn thing anymore. Pardon my French. I actually asked him, well, if I pulled a garbage man off the street, they wouldn't be a data scientist, right? And he said, I could probably put them through a 3-week boot camp in data science, and they would be better than some first-year data scientists I have met. So it is true that more and more and more people are using this term data scientist. And so in some ways, it means less and less and less. It also means different things to different people, and it's ever evolving. There's this one other distinction that I think is important to know, which is that I use all the time. There's this guy, Michael Hochster, who said that data scientists are type A, analytical, or type B, building. So analytical would be I look at data and try to draw conclusions. And type B would be I build tools that use data to do something else, most commonly recommender systems, but also other prediction systems, or they make facts. So here is the latest snapshot today from Data Scientist on Google Trends. So you can see right around 2011, this term starts becoming more used, more popular. And its popularity has only grown. There are discontinuities, weird discontinuity. Well, there's one weird discontinuity on this graph. And if you hover over that little notes thing in Google's Trends, it says something like, we have imported more data into our Google Trends system. So that's a very actually data science-y thing to happen, is the weird thing on the graph isn't reality, it's just computers. And that's things that data scientists look out for. But this term data scientist is not getting any less popular. I guess that doesn't mean that it means anything. But and so the plan today is to add questions to the dory. The dory is the thing on the right here with the scanning. And then you can also join the Minnebar Slack. I created a data science QA Slack channel. And I will continue to answer questions there as long as people are curious. That's it. Oops. Oh, this one. So now let me go back to the dory and see if there are any more questions there. Ruby Kraken has given us one more question. That's great. But now I would like to open it up to the floor for more questions. Just raise your hand, and I will take your question and type it in right now. No hands. People hoped someone else would ask questions. I can outweight you. Yes?
Here in Minnesota, we obviously have a lot of farms, a lot of agriculture, and agricultural data science, a lot of inputs and outputs are very much in vogue. One thing I've been reading about as an outsider, but very much interested in, is that there's a lack of sort of a unified architecture of the structure of the data, and that so right now it's a lot of individual firms working with individual farms, and it's becoming very fragmentized. And I was wondering if you had any input on maybe how we can, I don't know if we need a more unified or what the future looks like, but if you just had anything on that, I guess.
That sounds like an interesting question. So is there any standardization in agricultural data or data science efforts?
Yeah, data science.
Data science efforts. How could there be more? Is that reasonable?
Yeah.
Okay. Send. Okay. Yes.
Is that you hear that machine learning is the new statistics, but a statistician or a scientist might not entirely think so. Is there a sense in which machine learning is rigorous in a statistical sense, or is it something that just works?
Say that last part again.
Is there any sense in which machine learning is rigorous?
Oh, is machine learning rigorous, especially compared to statistics? Is that fair?
Is it mathematically rigorous?
Is machine learning mathematically rigorous?
In terms of producing correct results?
in terms of producing correct results, especially compared to statistics. Is that fair?
I think so.
Okay, send. More questions. Yes?
So what are data scientists doing to eliminate kind of personal preferences or personal thoughts that may impact the results of the data science?
What are data scientists doing to reduce the effects of personal preferences or leanings in data science results? Is that fair?
Sure.
Send. More questions. This is the strange thing about a group of 50 people. No one wants to ask, but this is this is the part of bar camp where it's just disorganized chaos. Go for it, people. Yes?
This is like an open question. So I read a paper of yours or like an article of yours from like 2017 where you said you were talking about like black box, how understanding the black box and how like not knowing anything about it is a really dangerous concept. So can you just, a quick question, like can you speak about your understanding of the black box?
Ooh. Let me see. What are some of the risks of not understanding how data science works? Is that fair? Send. Yes.
What are the most interesting or recent technologies around data science that are new and interesting kind of going forward?
What are interesting technologies, recent technologies around data science? Fair?
Yep.
Send. So hopefully, as you scan this little QR code here, and you don't have to type, you can nevertheless upvote some of these questions, and we will answer the ones at the top. Yes? Oh, go ahead. I want repeat customers second, new people first.
Okay. How do you select a good data science project, and how do you know when it's failed?
How do you know when a data science project has failed? Boy, that's really interesting. Okay, yes?
I've been Googling this and not finding the answer. How do you correlate categorical data and ordinal data?
How do you correlate categorical data and ordinal data? Okay, send. So I see more votes. There are only single votes, though, the ones with 3 votes here. This was here before we started, so not many people voting yet. But hopefully, if you scan on your phone, you will be able to vote or suggest questions.
Can you zoom in on the QR code a little bit?
Oh, QR code's not working?
Zoom in on the.
Oh, dear. How about this one? Does this one work?
Zoom in.
I don't, if I zoom in, it doesn't always get bigger. See, that's me zooming in. This one works. The one on the right there? Sorry. I will give that feedback to Dory.app that their QR code doesn't work.
Can I be your tech support again?
Yeah, sure. Bigger, even bigger. Thank you.
Session description too.
Thank you. Yes, the session description also has a link to the Dory. Yes. And I know this seems like a lot of time spent gathering the questions, but I actually think that this is potentially a part of the value, certainly to me, is what is this community interested in data science? So I find this useful, still useful. Okay, I see no more scanning, so I'm going back to the Dory and asking for more questions. And we'll start trying to answer the questions at the top soon. This is going to be great to watch after the fact in that camera, won't it? Me standing around waiting for people to ask questions. Someone had raised their hand over here.
I asked that.
Oh, okay, great. So there's already a question in the app. There are now 9 votes. I'm now, as a data scientist, starting to trust that there is some data in this voting. OK? Yes?
So when you look at the jobs posted for example, data sciences, most of the companies recently listed the skill sets. The title is saying data scientist, but requires everything from data engineering, software engineering, down to the management and executive level. So which one of the skills, besides knowing statistics, will be really helpful?
I see. Are there skills useful for data science other than statistics? How do those relate to job postings in data science? Is that fair? OK, send. So it's 118. At 120, we'll take whatever's at the top of the list. People are voting. It makes me happy. We're gathering data right now. Can you feel it? I can feel it. More questions? Unfortunately, you have to do 2 things at once. Well, ideally, what we would do is we'd have a session to gather up the questions. Then we'd tell you to vote on your own time, and then we just answer the questions. And then in another session, we can't have 2 sessions. I guess I could have made 2 sessions. This is an experiment. Minnebar is supposed to be, I think, a little bit more just experimental, playful, interesting, open sometimes. I've seen a lot of great presentations here so far, though. Other questions?
Will there be questions in the middle? Because I think I just need to learn more context before
OK.
I ask a good question.
There might be, yes. One more minute for voting and questions.
Action pose. Gotcha.
All right. So it's 1:19. I'm going to be early. So at the top, what features are important to consider when choosing a career in either data science or software development, especially for someone without any experience in either, aside from academia? This is an interesting question, and I do have a lot of thoughts on this. There are many aspects. So first of all, what is your day-to-day? I don't know. Do I have to speak through this thing? I don't think so. I have a lapel mic. They'll hear, you hear. Your day-to-day is potentially somewhat different. And it's a little bit hard to describe in detail if you've never seen any job. But in software development, you think being in an IDE, like integrated development environment, typing software code, thinking about unit tests. There's always something that's broken or on fire. There often is, if you're in a consumer-facing app, there would be pager duty, like what if the thing breaks? There's operational aspects to it. A lot of software development, I think, is really moving bits from hither to yon, moving bits from one place to another. Store and retrieve is also called, right? Like enter stuff in, make sure that that stuff gets from one place to the next. That's actually a surprising amount of software development. There is software development that is not that, but at the foundation, you have to get computers to work and work reliably. There's a lot of focus on detailed engineering to get that to work. Data science might more often be, let's think a little bit. Well, I would split into type A and type B, type A being analytical, type B being building. So type A, you would be thinking, as my friend Shalad's talk pointed out so well, like what questions are important to answer for the business or for the organization that you're in. And often the people who are asking you to do something are asking you the wrong questions. They don't know what they want. And you have to look for the question behind the question, as people always say. There's a negotiation over what's Right. I mean, there's negotiation in software development as well, but you're answering questions. Then you go to some data, and you want to make sure 80% of the job will be getting extremely dirty data into a form where you can actually use it to do something. Potentially no unit testing at all. Potentially much less structure or discipline around software tooling. Like, do you like building a piece of software that works, or do you like answering a question about some data? So your day-to-day feels very different in those two disciplines, in my opinion. The type B building data scientist might be more in the middle of that, where you are building a thing, that thing has to work, that thing is often implemented in software, so you have to be at least part a software developer. But you'll see a lot of organizations that build up competencies that support building data scientists so they don't do all of the software because they're too expensive to have them writing tons of unit tests. You have people called data engineers who sometimes take over some of the tooling to move the data around so that you can build your machine learning models. There are parts of the software that you don't have to build because others have built it for you. So the day-to-day feel of that thing is very different. Another difference between data science and software development is the life cycle at which you might come into a company. If you come into a company that's just starting up, they almost always need software developers. They don't always need data scientists. They'd love to have some data science, but they don't actually have any data. It's surprising how often you will encounter people who want to do really cool things, but don't have any data to support it at all. They view data science as a magic box where you put all of your hopes and dreams in the left side of the box and money poops out the right side of the box. But they don't really know what's going on in the box. And so the stage of company that you can come in on is very different. Like when I joined Pinterest, I was about employee 100. They wouldn't have hired me as employee 10. They just wouldn't. That wasn't what they were focused on at that moment. I feel like salaries are different, but I don't know a ton about that. Up until recently, I would have said that data scientists were more rare, hence perhaps a little better paid on average, but I don't know if that's true. I would like to invite my esteemed colleague Shalad to see if he has any comments on the differences between data science and software development.
I think one difference in your day-to-day life is in data science, you're often working individually on a question or maybe with a partner, and you might bring your findings to a larger group, whereas in software development, you're often working much more collaboratively with a larger group.
That is a really great point. Yeah, the organization, the structure within the org is usually completely different for data science and software development. As you said, software development has these large teams of software people all working together. Data scientists can often be on their own or partnered with maybe one other person or something. Sometimes they'll be organizationally different. So you'll have a centralized group of data scientists that all hang out together, but are all working on different things from each other. And they're all talking to different groups in the org. So organizationally, very different. Do other people in the room have thoughts about the difference between data science and software development as a career? Looking around. Yes?
There's a big communication element to data science, isn't there? Not just understanding the data, but being able to tell a story.
That's a really great point. So I wrote a blog post about how to become a data scientist, actually 4, part 0, part 1, part 2, part 3. And my definition of a data scientist is someone who understands computers well enough to manipulate large data usually, someone who understands statistics well enough to draw conclusions from that data that have some confidence, and someone who has communication skills that are good enough to present their conclusions to sometimes a non-technical audience. Does that jive with your thoughts?
So where does that overlap with software development? Where does it?
There are some software developers who are really good who are not intelligible. That is less often the case with data scientists, probably. Do others have thoughts about the differences? Yes.
I guess I have a question about that. You see sometimes that a data science training would include calculus or linear algebra. Is that actually needed in a data science job?
Is linear algebra needed in a data science job? No. Would it be useful? I think so. This is almost a religious position in that, do you believe that knowing how math works helps you reason about your tools? And I think it does, but it's not a direct application often. It just gives you context to understand how things work and whether they would work. Solutions that are susceptible to linear algebra can often be efficiently enough implemented that you can scale them. Google used to describe itself in one way as finding the eigenvalues and eigenvectors for the internet. So you put the entire internet in memory, and then you run a linear algebra program over the entire internet. That's an algorithm that's scalable. Whereas if your algorithm doesn't have anything to do with linear algebra, it's less clear if it's scalable. So that's sort of an insight about how computers work, where math helps you. But you could probably use Google without knowing it. You could probably work at certain aspects of Google without knowing about that. OK, let's move to perhaps the next question. How do you select, so I'm not going to archive this. How do you select a good data science project? How do you know when a data science project has failed? How do you select a good data science project? So many aspects. I mean, the first one I always think of is this important? But importance is so many different things to so many different people. To a business, I think important is, will the result of this materially change how the business operates? That could be related to their users. It could be related to revenue. It could be related to the internal stories, what they tell themselves. I can give you an example. In 2015, the CEO of Pinterest, then Ben Silbermann, declared internally that 2015, oh, I'm being recorded. Well, no one will watch this. That 2015 was the year of international. And what he meant by that is that Pinterest would make a concerted effort to work better outside the US. Concurrent with that, we started to have more data sources available about the language that our users were likely to be speaking, the country that our users were likely to be in at the moment they were using Pinterest, and what the language of the pin on Pinterest was likely to be referring to. So for those of you who don't know Pinterest, Pinterest is a pin board with pins. Each pin is an image, but associated with that image can be a link, so that when you click on the image, it takes you to a website that was linked to that image. And so we could look at the website and try to guess what language that website it is in. And we could also try to guess what country was that website hosted in. So there was a data source internally coming online related to whether our users and our content were international in some way, language and country. And pardon me, I spent the next year producing graphs and stories about how well we were doing for our users outside the US. And the answer at the time was, we could do a lot better. And the reason that that question was important was because it was directly related to what our CEO said we should be doing. But if you're not at a business, I mean, a completely different example is there are all of these systems doing facial recognition, and you could ask the question, what is the performance of facial recognition on people of different races? And the answer is the performance is highly different depending on what race you are. I don't remember the exact results, but one result I remember was that facial recognition was much more likely to be inaccurate if you're black. That's not something related to some business goals, but it seems like a very important question and one that, that was widely publicized both in the industry and in the newspapers, and seems likely to move how people do things, or in the best case it would. So the first thing is it important? The second way to select a good data science project is, do I have the data? It's incredibly common for people to want to answer very important questions that they do not have data for, or do not have clean data for. People often think, well, I have a lot of data, so I must be able to answer this question. And that is not true. More is not better. You need the right data to answer the question. And if you don't have the right data, it doesn't matter how much data you have. And in fact, often if you have a lot of data, it's really noisy and useless. So do I have data and the right data to be able to answer the important question I've chosen? Do people in the room have any other thoughts about how to select a good data science project? Yes?
I was told that it has to speak to you. Like whatever project you're picking has to have some importance, otherwise you're just going to kind of let it fail at some point.
That's a really great point. So do you have a personal connection to this problem? Do you have enough personal energy that you're going to pursue it, despite the fact that the data is dirty and your boss is telling you that this thing isn't important or that we have other priorities? Are you going to be able to carry it through to the end? One thing I would say perhaps in relation to that is ideally you would shrink the time from which you start the question and have some results that you can show to be as small as possible. You don't want to plan a 6-month project. You want to plan a 2-week prototype where you start, you grab some data, you see if you have anything to try to keep that motivational window short. And then if you do have something, maybe your motivation increases or decreases. Do other people have thoughts on that, on good data science projects? Yes?
Cost, time scale, as you said, because you might think that it will take 6 months, but it might take 6 years. So, and then what is the output that you want, and how timely is it? Like after 6 months, maybe the project is.
So 2 other aspects I'll repeat for our friends on the microphone. One of them is cost. How much is it? If this thing is going to cost too much, we should not embark on something we are not willing to support. And the second one that is related is timeline. So I have a rule of estimation. I took it from software development as my own rule. I'm sure everyone has their own rules, which is if you estimate that it's going to take some amount of time, your estimate is plus or minus 100%. So if you think it's going to take a month, it might take 2 months. It might also take 2 weeks, but that's less likely. If you think it's going to take 3 months, it might take 6 months. And if you think it's going to take 6 months, you no longer have any idea of how long it's going to take. It could take 5 years. So you cannot estimate any longer than 6 months. So that's my personal rule. Other thoughts about picking a good data science project? Yes, sorry.
Yeah. So one of my thoughts on it is that with data science, with data science like any other kind of science, like I always like to think that the easiest person in the world to fool is yourself, and that you have to find a way to be on guard for that. And I always kind of feel that one of the most useful ways is to be investigating the question that you have enough of an intuition and built-in experience with already that you can tell when you're drawing invalid or questionable conclusions out of it.
So that is the classic science skeptical stance, which is I'm going to ask a question and I'm going to act as if I do not know whether the answer is in the positive or the negative, the affirmative or the negative. That is a very uncommon stance in the world. So the scientific skeptical stance is very uncommon, very useful in data science. You say the easiest person to fool is yourself. I think it's actually a lot easier to fool other people. You can fool yourself all the time. You should be skeptical. I find that other people are even more, see, you're skeptical of my answer. Other people are even more accepting of falsehood than the skeptic is. So one very common risk, in my estimation, is that people take data, they draw a conclusion from the data, and then they're like, great, let's go. And so the data scientist has to stand there and be the skeptic to some extent and say, do you actually have confidence in that result? And you're saying you have to apply that to your own investigations, and I concur, but I think the risk of others investigating is even higher. You can feel free to disagree. So I'm going to move on to the next question. How do you know when a data science project has failed? If you don't get some result quickly, you're probably in trouble. Some result is a prototype result. You have tried something for a few weeks and you're nowhere. You may have stepped into a large hole that you're not going to climb out of. That's not failure for sure, but that's a yellow flag. It's a risk. You know if it's failed, I suppose, if it doesn't produce results that anyone cares about. That's probably the most typical failure point, I think. Data scientists, I think, hopefully in the best case, are curious people. They're like, oh, here's some data, let me look at it. And that in itself can be pretty bad because if you approach data with no hypotheses in mind, you're going to come out with what you came in with, which is nothing. I've seen people produce tons of graphs, and I have no idea what they're getting at. You can spend a lot of time on that. So if you produce results that no one cares about, that would be one mode of failure. Another mode of failure that I've been alluding to, which is harder to detect, is if you produce great results, but they're actually not real. This does happen, I think, where, and I would claim it happens more often with software engineers. Sorry to my software engineer pals, where they're like, grab this data, pipe it through the system, now we have an answer, let's go. But the answer is actually wrong. Do people in the room care to speculate on other reasons why data science projects, where you know data science projects have failed? Yes?
But bad data, dirty data, then within companies, people don't want to share, the producers don't want to share the data.
So a yellow flag is if people don't want to share the data that they're using, that's because they don't want you looking too closely, because they're bamboozling or they're fooling themselves. Other yellow or red flags for data science projects?
It's like maneuvering over different algorithms. If one or two didn't give you the results at the first point.
Aha, so you think you have a problem, you think you have some data, you chose an algorithm, you got a result, but you don't like the result for some reason, and now it's time to go look for a new algorithm to get a different result that will be better. You can imagine changing algorithms and getting better results. The more often that happens, the more likely it is you're fishing around and you're never going to end. That seems to be plausible. Yes?
I actually sort of wonder about that because in science, you do adapt to what you find sometimes. Like, if you ask a new question after you find something, maybe that's okay, but if you go back and reanalyze the data after having cut things, and you cut too much, maybe that's not.
So you're saying it's fair to iterate on projects and choose new questions, new data, new algorithms. It is fair. And actually here, I feel like unfortunately, there is no right answer on this one. So I'm reading a great book someone recommended to me called Genius Makers about the people who pursued deep learning neural networks. I'm 2 chapters in, and it's fascinating so far. One of the characters is a professor named Jeff Hinton, who I think in the 80s, but certainly by the 90s, firmly believed that neural networks were going to be able to solve problems that other AI techniques would not be able to solve. And there was an important AI early researcher, I think at MIT, named Marvin Minsky, who's making fun of Jeff Hinton publicly all the time. He was saying symbolic AI was the way to go. You represent the world in concrete symbols, and you learn how to manipulate those symbols. That's how you were going to produce artificial intelligence. All this neural network stuff where you're simulating neurons that are connected to each other with mathematical functions is never going to amount to anything. He hung on to that idea like a badger for 30 years. And after 30 years, there were there were breakthroughs all along the way, but you can actually trace to 2012 some enormous breakthroughs in image recognition where everyone woke up and said, oh my God, this neural network stuff is really something. In particular, deep learning neural networks, which is a kind of neural networks with lots of layers, seems to be able to solve problems that we couldn't attack before. So that was massive iteration, right? Over years, over decades. Lots of people can't afford to iterate over years and decades, so there are trade-offs.
Sorry, I didn't mean to be rude.
Other thoughts about when a data science project has failed? My screen came back, but this one didn't. OK. OK, I'm going to move on to the next question, which is, how are data science teams effectively organized and deployed and utilized at small, mid, and large organizations? Boy, there are classic debates here. As alluded to previously, data scientists are often organized in organizations very differently from other engineers. 2 ways that are very common. One of them is embedded. So embedded in teams, you'll have a team that's building a certain thing. That team might have 10 or 20 people, and you'll have one data scientist that is also in that team and responsible for goals that are very related to that team. A classic example would be a team that produces a recommender system. Say the home feed team for Pinterest. When you land on Pinterest, it shows you some pins. A bunch of those pins are recommended through artificial intelligence, through machine learning. There's a team that builds the recommendations for the home feed, and there will be machine learning engineers on that team helping to form those recommendations. The upside of that form of organization, the embedded form, is that you're very directly connected to the problem and influencing that problem. And that direct connection allows you to be productive within the organization. A downside is you're often very isolated. Whatever other data science is happening at the company, you're not well connected with it. If there are advances in data science as a whole, you might not be as well connected with those either because you have no community where you're all communicating these things. Another downside with that is you're usually judged very differently from your peers. So if you're looking for promotions, for raises, you're different than your peers in the organization. Another classic organization for data science, way that data scientists work in an organization is centralized, where you have a team of data scientists all working together, all associated with different teams. The upside is they have a community. They can talk to each other about the problems that they're working on. They can keep up with progression in data science as a whole more easily. A downside is they're not always as well connected to the problems within the organization as they could be. Sometimes you'll have a data scientist in search of a problem because all the teams in the company don't have a connection to the centralized data science team. And people go both ways. Do others? Oh, we're almost running out of time.
We need a time check. We need a time check. Can someone tell us how much longer we have?
1:48.
Couple minutes?
Couple minutes. Do others have comments on this? Questions about how data science teams are organized? Are there other methods of organization or pros and cons? I think we might, if we're over at 150, we might wrap it here. The one thing I would do is claim that there is a Slack that is linked off of the page. And I am going to endeavor to write some answer to every question on here that has at least 3 votes, because 2 is a very long tail. And I will write them in the Slack if you wish to join. Thank you very much.